Okay, good evening once again, everyone. Welcome to week 6, session 12. So today we'll be continuing from where we stopped from yesterday's class. We're going to kick off right away, and we're going to continue with pandas. So yesterday we introduced us to pandas and what pandas library is used for. And I also introduced, we talked about pandas data structures like series and data frames. We also looked at some of the attributes of series. All right, we looked at what a series is, and we looked at characteristics of series. Talked about how series are homogeneous in nature. They have flexible indexing, and they have alignment via indexing when you want to perform some operation. And we also looked at the basic operations you can perform on series. We looked at how we can slice our series, how we can perform arithmetic operations, and how we can handle missing data as well. So we looked at also some other things, vectorized operations and conversion to other data type. So we then jumped into Pandas data frame. We looked at what Pandas data frame is, and we also looked at the characteristics of data frames. We also looked at some of the characteristics which are labeled as the axis. It has both rows and column axis, unlike series that has just row axis, right? So we said that a data frame is a two-dimensional data structure. Series is just one-dimensional. We talked about how a data frame is heterogeneous in nature, meaning that each column can have different data types, right? Column 1 data type does not necessarily have to be the same data type with column 2, so they can be different, right? So we talked about some other things and how efficient it is, right? So we also looked at size mutability. So some of these things are things we are going to expound on and talk more on in subsequent classes, right? So today class is going to be one of those classes where we're going to expound and talk more on data frames. So we actually looked at how we can create a data frame from a dictionary. All right, so we saw we can create a data frame from a dictionary. Then we also looked at how we can get some of the attributes of data frame via some attributes. So we looked at df.shape to get shape of our data frame. We looked at df.columns to get the columns of our data frame. We looked at df.index, df.data types, dtypes, df.size, df.ending, df.transpose, which is to switch the rows and columns. We looked at df.values as well, right? We get the values of our data frames, right? So all these things, most of these things we usually return, especially this df.value, right? And df.column and index, they usually return the output in a NumPy array, all right? So you can work with them and use them to do whatever it is you want to do. So today we are going to continue from where we stop, and we're going to look at basic data frame operations. All right, we're going to look at basic data frame operations. We're going to look at how we can view our data. We're going to look at how we can select columns and rows. We're going to look at Boolean indexing. Then we're going to head on to look at how we can manipulate our data, adding and removing columns. We'll look at how we can handle missing data. Then we'll jump onto data aggregation and group operations. We're going to look at how we can use our group by function to group our columns, right? We're also going to look at aggregate function. We're going to look at date and time handling, all right? And we're going to look at advanced data manipulation techniques and so many other things. So this is basically what we're going to cover today. And I wanted us to just look at these things today and then jump onto CSV files in the next class. But I think it's better I should just use CSV files to demonstrate everything we're going to be doing today. So that is basically, hopefully we get to wrap up with some of these things. Anyone we can't finish today, we'll then push it to the next class. So next class we'll finish up with pandas and then move on to data visualization. Hope everyone can hear me clearly. All right, great. So let's kick off with it. So now we've looked at, we're going to be looking at working with data frames. Data frames, all right. So first thing first, we're going to, let me just make this. So first thing first, you have to import pandas. Import pandas as what? PD. So now, to work with a particular file, what we did yesterday was I showed you how to create a data frame from a dictionary. All right, that's not what you're going to be doing. When you start working with pandas, you will not be manually creating data frames from dictionary. Rather, you would be using files like CSV files, Excel file, and any other file that it is that you want to that has your data. So you basically want to import your data, right, into Python and use pandas to analyze it, right? That is usually the aim of like working with pandas. So it's just the same way you open your file, your CSV file with Excel and use Excel to work with it. So you need to like import your file first before you use it. So to do that, what you would normally do is that you will have your file, and there are some things you need to like pay attention to before you import your file. So right now we have a file, right? And that file should be in the same directory as the same directory with your Jupyter notebook. So where you have your Jupyter notebook, make sure that you have that particular file in that same directory or folder, right? Let's assume you created a folder, CareerEx folder, and you have some files there. You have your Jupyter notebook files there. If you want to like import any CSV file that you work with, make sure that CSV file is in that same folder. This is just to avoid complication and avoid giving yourself headache. So it just make things easier for you. All right. So that is something to take note of. So once you have that in your folder, then you come here and let's say importing my CSV file. So what you do now is just like, you can either create a variable or just pass the file name directly. So I can just come here and say file name, and I will say the name of the file I'm working with is customer booking .csv. If I'm correct, this should be the name. All right, make sure you get the exact name. If you don't, you can always go to check. Let me check here to see the customer booking.csv. This is exactly the same name. So then you have your file already. So there's a particular function that you use to read your file. So Pandas has a function called reading file with Pandas. So Pandas has a function called pd.read CSV. So this read CSV is a function in Pandas that actually pass through your CSV file and convert it into a data frame. That's basically what this read CSV does. It passes through your file, your CSV file particularly, and then convert it to data frame. It has other they have other functions that passes through other files. Like if you're importing an Excel file, you can actually use Excel, read Excel, right? But the most common file we use is CSV, so we're going to just come here and say read CSV. So that is basically it. So you're just going to like what the things you're going to pass. And let's just do what we do normally. Now there's something I want to introduce us to. Normally, if you want to get to know what a function does or a method, you just put question mark and then it will give us all this thing. So to avoid this extra step and all of that, you can just have your function here and bring your cursor on this function. Just place it anywhere in the function. and press Shift Tab. You get, so you press Shift and Tab together, it will give you a pop-up, all right? So this pop-up is the same thing with the question mark that you usually use. So this pop-up it's just like a more convenient way to read through the documentation, all right? So if you just click outside of it, it will disappear. So you come here, Shift Tab, then you get the pop-up, all right? So once you get the pop-up, you can just scroll through to read everything that is there. So you can see what this does is that, so this is the function argument file path. So it takes the file path, separator, delimiter, header, this, that. So it has a lot of argument, right? Which you're not going to be using everything. So if you want to know what each argument does, you can just scroll down and you see them explained here. So for file path, this is a string path object or file-like object, right? Any valid string path is acceptable. The string could be a URL, valid URL scheme. So you can pass in anything there. If your data is actually, you can just get the link and then put it into this file path, and it's actually going to pass it for you, right? So it's very, very powerful. It's a very, very powerful tool. So what this particular function does is that it reads a comma-separated value file into a data frame, as I've explained. That's basically what it does, all right? So let's just go ahead with it. We're going to put our file. This is our particular file path. So the file path is actually where this particular file is located. The reason why I told you to make sure it is in the same folder is so as you can just pass the name directly without having to start getting the file path and all of that, right? So you just get this variable here and just say file name. So that is all you need, and then you run it. So if this runs correctly, it should give you this a data frame. But I think there's an issue. We have to check to be sure that we are getting the correct file. It's telling me that no such file or directory, customer booking or sales. So I'm going to have to check again to be sure that this is in the same file, the same path as it. So customer booking, this should be it. So let me just copy the file paths and then bring it back here. Customer booking, sure. Let me just put the file path directly. So you can see the kind of things that happen. So you need to make sure that you have your name correct. So let me just quickly figure out what this issue is. So customer booking. Okay, this should work fine. Just let me copy this right. All right, so let's see. Okay, let me get a new file. I want to be sure that this notebook is in the same file path. That is untitled 4. Untitled 14. Okay. I see the problem now. That particular file I was working on is not in the same file path as this, so I need to come here and just create the file directly, so it's under the same folder. So you can see how that can actually be an issue. If I come here, you can see it's already here. So just come here and say import pandas as PD, and then come here and say importing and reading CSV file. So I'm gonna have say my file name is equals to customer booking.csv. So pd.read CSV. What's my file name there? All right. So there's another shortcut that I use. Some of you might be wondering how I just auto fill whatever it is I'm typing. So if you're typing any variable name or any Python function or whatever, you can just press, as you're typing, you can just press tab. Python will give you some options. So it looks at the environment and kind of matches the environment name with the variable, with the name you're trying to type out. So it gives you options. So if you see the one you want, you can just select it and just press enter, right? That's basically what happens here. Right, the code. So this is my CSV file here. I have imported it into Pandas, all right, and it has converted the CSV to a data frame. So you can see now that I have, my name is zoom out so you can see it very well. I have my CSV now in a Python, in a Pandas data frame. So this is mostly, or this is basically what you see in Excel as well. So you have all your columns and you have all your rows as well. You can see the rows are actually your normal integer index, they are not custom index. And you have your columns here, like indicating the name of each column. All right, so you can see that each column have different data types. This is an integer, this is a string, this is a float. So this is basically what we're talking about when we talked about heterogeneous data type. All right, so this is a very large data set. So we're going to use this to explain exactly how data frame work and how you can interact to data frames. So this is basically how you import your CSV file into Pandas. Very straightforward, but make sure that you have your file in the same directory as your notebook, as the notebook you are working on, right? You can see how that caused a little issue initially. So I have to make sure that the file I am working on, the Jupyter notebook file I am working on, is in the same folder as my file, the CSV file I'm trying to import. So that does, so you don't have, or you don't get headache. The reason why I was able to just quickly figure out the error is because I already know where the issue is coming from. But if it was something that you are doing for the first time, you might spend hours and sometimes even days like trying to figure out what the issue is, and you'll just be stranded, right? So just for that kind of issue, make sure that you have this appropriately configured, right? So when you come to the group and you're telling me that, CEO, I'm getting this error, I can't figure it out, and I look at the error and I see that this error is because of this, I'm not going to respond to you because I'm sounding it now, right? So once you import your data, now you can now try and you can now work with your data frame. So let's just follow through what we have here already. So we've looked at the characteristics of our data frames. So now we're going to look at basic operations on our data frames. I think that's where we are. Yeah, basic data frame operations. So the first thing you want to do is you want to view your data, all right? You want to view your data. Normally, when you import your data set, it gets imported and displayed like this, all right? It is displayed like this, but the reason why it is did immediately is because I didn't pass it into a variable, right? I didn't pass it into a variable. So now I'm just going to pass this whole thing into a variable so I can use the variable as much as I want. So I'm just going to make it df as the variable. So df is not going to be carrying the content of my data, content. So if I come here and I say I want to view my data sets, all right, let me zoom out a bit too. I want to view my data. So to view your data, there are two methods that you basically be using, right, all the time. So two of them are df.head. We have df.head and we have df.tail, right? So what df.head does is that it gives you the first, by default, it gives you the first 5 rows of your data, right, of your data frame. Let me just use data frame. It gives you the first 5 rows of your data frame, while df.tail gives you or returns the last 5 rows of your data frame. So if you quickly come here and press Shift and Tab, you will see the documentation here. df.head, number of rows, by default it is what, 5, unless you change it, all right? So it returns the first n rows, but by default they've made it 5 here. So when you don't specify anything, it's going to be 5 rows. So this function returns the first rows for the object based on position. It is used for quickly testing if your object has the right type of data in it. So that's basically what it does. While tail does hope everyone can see me clearly. My network got off for a while. Went out with, I think it went out for a while. Can everyone see me? All right, great. So let's just continue because of time. So to use this, you basically just come here and see df.head. That is all. Don't need to do any other thing. If you run it, you're going to see it's going to give you the first 5 rows. It will return all the columns as well, but it will give you the first 5 rows. So you can see it here, 0, 1, 2, 3, 4, 5 rows, and then all the columns as well. All right, so this is basically how you can like view your data. If you want to view the last 5, you can use the tail. All right, come here, use your tail and run it to give you the last 5 rows. You can see the last 5 rows. So this data set has up to 50,000 rows. So these are the last 5 rows of your data set. So you can just view it. It just help you to understand the kind of data that you have or that you'll be working with. All right. So that's the initial thing you do most times when you import data. Right. So if you want to configure how many rows it should give you, you can just come here and put a number that you want. If I put 10, it's going to give me 10 rows, first 10 rows. Right. If I put, it's going to give me the first 2 rows. If I put 3, it's going to give me the first 3 rows. If I put, so any number I put there would be the number of rows that will be returned to me. All right. So that is basically it. Very straightforward. The same thing for tails. So if I come here and I put 5, it's going to give me the last 5 rows by default. If I put 10, it's going to give me the last 10 rows, and so on and so forth. So I think that's pretty easy to do. So there's another function called sample, df.sample. So what this function does, let's just see. What the function does actually is that it gives us a random number of rows. But by default, it just gives us a single row by like a random single row. Right. So if I run this, you'll see that it just give me 1 row by randomly rather. If I run it again, it's going to give me another random row. You can see 43295. If I run this, it's going to give me another random row, 12,732. All right. See, we just started this thing, right? All these questions that you're asking now, we are going to look at everything. It's probably when I'm halfway done the class, or I'm done with the class and I didn't mention it, that you can now start asking questions, because we are going to look at how we can check the number of rows and columns and all of that. So we are basically just starting. So let's not rush. Let's try to understand the one that is being explained at the moment, right? So if you already know this thing and it's familiar to you, just I don't know, wait till when we get to the point you probably need. So randomly, you can get samples. So if you want to change the number of random samples, random number of rows, you can just put the number here. So let me just put 4. If I put 4, it's going to return to me 4 random rows. Like, it does it by random. It just shuffle it, kind of shuffling it and picking rows at random to give us. So if you want to just see how your data is randomly, you can use a sample. If I put 5, to give us random rows, 5 random rows, right? So these are the functions that you'll be using mostly to kind of just check or view your data. All right. So df.head, df.tail, df.sample. So this gives you a good glimpse of what your data is like, and from there we can now start working your data. So that's basically it for viewing your data. So let's now move. Now remember, there's a function I told us yesterday that we should use while printing our data to the output. So what can someone just remind us of that particular function? So there's a function that we talked about yesterday. Exactly. So I want us to have that at the back of our mind. Let's always use that display function, because if you come here and you see df.head, and I come here and see df.sample, we're not going to get this head output, right? Because of how Jupyter Notebook is. It always output the last code for us here. So to get this, you can use print, which we normally do before. So print is going to give us something like this. You can see how jagged it is right now, how scattered it is. So if you have a lot of columns, it is just going to be scattered and won't make sense. This is why I told you not to use print, right, for me. So you rather use display. So display would give you the data frame in the normal format, right? So you use display for me instead of print. If I give an assignment and you use print, it's going to affect your mark, but it's going to affect your score generally. So just take note of that. This is the second time I'm talking about this. Let's let you know how important it is. So let's go on to the next thing that we have here. We have selecting our columns and rows. So now we've looked at how we can view our data. So let's now look at how we can select columns and rows. So before we do that, there are some basic things that we've done today, right? So from what we've done already, we can see that we can just quickly assess our data frames to know how many rows we have, how many columns we have. So if I come here and see df.shape, this basically now, this shape now would now make sense to us. It is not going to hold a particular meaning. Remember, we've been doing shape in NumPy arrays and even in yesterday data frame. The shape is just X and Y axis, right? But now the shape is now giving us a meaning. So this 50,000 rows, 50,000 num value here corresponds to the number of rows in our data frame. So from this, you can know that, our rows have 50,000, our data has 50,000 rows. Why this 14 here corresponds to the number of columns our data have. So you can see our data set has 14 variables or 14 columns. So variables and columns are the same thing. So we're going to be using them interchangeably. So this is how we can quickly access our data frame to know how many rows and columns that we have. for that person asking that question. I hope this answers your question now. So that's basically it. So now we can now move on to assessing or checking out different other details in our data frame. So to get our columns, how can we get our columns? Like to get the names of our columns in this data frame. I gave us the function in yesterday's class, or rather the attribute. So how do we do that? Are you sure it has a bracket? Does it have a bracket? Felix. So we use df.columns for that. So df.columns is going to give us the column name. So you can see if we run this, we're going to get all our column names in a view. So instead of scrolling from left to right, trying to see all the column names, so you can just use df.column names, and at a glance, you're going to get everything. So you can see that we have this number of columns. This column, we have 14 columns based on this df shape, and these are the 14 columns that we have. So you can see everything at a glance. All right. So there is also another function. So one thing about libraries in Python is that most of the things you're going to be learning are functions. Right? Functions, you're not going to be like doing like to do certain tasks. You will not have to like go through some rigorous process or writing code and all that. Most things have been wrapped up in a function for you. So it's just when you want to perform some complex task that does not have a function that you cannot start defining your own default function, right? So most of the things you're going to be doing, they already have functions for it. So for getting your columns, this is the particular function, but technically this is called an attribute, not a function, because functions usually have bracket with them. So this is an attribute, right? So this is to get the columns for data sets, right? To get your index, which I've already told you, just say df.index is going to give you your index. So it actually gives you the range, right? The range starts from 0 and ends at this 50,017, right? So this is basically how you get your index. If your index is not something that is a range, like something like that, maybe it's a string, it will give you everything like as a list, to return everything as a list. So now just pay attention to all these functions and attributes and everything we're going to be doing. So this column has an S, right? So make sure that you don't miss that. If you miss that, you get an error. So all these things are still very, very important to note. So there's another attribute, which is df.info. So what df.info does is that it gives you an information about your data set. Right now, okay, this is actually a function, not an attribute. It's a function. So what this function does is that it gives you a comprehensive information about your data frame. So there are 4 columns here. Three columns, yes. This first column, second column, and the last column. So the first column corresponds to the columns that you have in your data frame or variables, as you will. While the second one here corresponds to the number of not null rows. So I'm going to explain what not null mean. So why this last row here, D type, corresponds to the data type of each column here, right? So you can see we have 14 columns, right, from 0 to 13, which is 14. And then for each column, we have our not null. So what not null means is that how many of our rows in that column have is not null. Not null basically means missing value, right? How many non-missing value, how many valid values are in that our column. So when you start working with data set, you realize that some particular rows have missing value. So the way Pandas interpret it, or the way it is represented as null, right? Null or NaN, either of them. So whenever you see that, you just know that this is representing a missing value. There's no value here, right? Probably the person that was inputting the data forget to put data in that particular place. So this particular not count all the valid values in our column and returns it. So you can see that this column has a complete value. So this one here, purchase lead, it does not have some of the rows are actually null, right? Some of the rows of this one are null. So you can see the particular number of not null values in our data set. So the last column here is the data type for each column, which is pretty straightforward. So there's some information on top too. So the first information here is the data type of our data, right? So it's a data frame, as we all know. So this second information tells us about the range index. So it tells us how many rows we have in our data sets. So we have 50,017 entries, which basically means rows. So it gives us the range, right? And also gives us the total number of columns, which are 14 columns, right? So at the end, we have some other information. So this is the summary of the data types. So we have 7. This value in the bracket is the number of float 64 that we have. We have, out of all the 14 columns, 7 of them are float, 2 of them are integer, and 5 of them are object, which is probably string, right? So, and the memory usage of our data frame is 5.3 MB. So this particular data frame we have now is using 5.3 MB in our system or in memory. Right? So you can say it's actually large, right? So having 50,000 rows is not a small thing. So this info function will give you a comprehensive information about your data frame. So these are the things that you do when you start or when you import your data frame and you start like working with it. So I think it's pretty easy to work with Pandas, because you can see how easy it is to just write code and you're getting certain information out of that. But there are still a lot of things we will talk about. So that's it about getting to know your data. Although there are still some other things or a lot of other functions, but these are the basic functions that you get to familiarize yourself with. So now, okay, we're about to look at how we can select rows and columns. So let's assume you want to select a particular column, like you want to work in a particular column or you want to understand a particular column here, right? You do that by, I think we did that yesterday. So can someone just like quickly remind us of it? So I think we looked at how we can like get a particular column from our data frame. And I said something about it being a series. Each column in our data frame is a series, like a series, or is a series basically. So when we extract it, it is extracted in the form of a series. So everything you can do on a series, you can perform on a series, you can also perform it on that particular column. All right, so I'm still waiting for us to quickly show us or tell us how we can extract or get a particular column from our data set. Hope we've not forgotten it. Okay. Are we sure? Please look well at what you just look well at what the code you're writing. Is that correct? Okay. Felix actually got it. So how we do that is actually saying df. There are 2 to do it actually. You can use the normal indexing, right, method by putting your 2 square brackets, and inside the square brackets you put your column name. So we know we've gotten our, let's just quickly get our column names again here. Df dot, let me just say print df dot columns. These are our column names bar. So I want to get let's say sales channel. All right, I'll come here and say df and say sales channel. Right, I'll make sure that this string I have here corresponds to this string that is in the column there's a column name. It must be exactly the same thing, right? Unless we're going to get an error. So if I run that, I'm going to get this. I'm going to, so this is like, this is a series object, right? And it corresponds to the column sales channel, right? So now there's something I want us to know. We can actually perform the same thing on our series as we can do on our data frame when it comes to viewing. So if I come here and say head, we're also going to get the first 5 rows in our series. If I say tail, or if I type tail, I'm going to get the last 5, right? If I come here and I say sample, so there's some functions that you can use on both data frame and series. So as you go, as you practice, you get to learn about these different functions. So just separate them. So they just make it look neat. So let me just do it this way. Times 7. All right. So yeah. So this is our sales channel column. We've extracted it, and how we did that was by just coming here and saying df, and then we put the sales channel as a string inside this bracket. So there's another way to actually do it, right? So we can come here and say df.salesChannel. Actually, like remember I told you that each column is an attribute, all right? So you can actually call it as you call an attribute. So you can just come here and say df.salesChannel. Now there's another shortcut that I just want to show you, which will help you. Okay, I think I've told you that already. If you press tab, you're going to get an option. I think this should work. So you're going to get like an option, like an auto-completion option. So this sales channel is one of them. So if I just press tab again, you're going to complete it for me. And then I'll run that, and I'll also get my sales channel column here. So these are 2 ways you can get a particular column, either by using the indexing method. So this is the indexing method, or you use the normal attributes method. All right. So you can call your column this way, or you call your columns this way. So now one of the perks or advantage of using this particular method is that you can call multiple columns in this particular format. If I come here and I say df, and I want to call 3 columns, all right? How do I do that? I'll put it inside another list, all right? I'll put a bracket inside that bigger bracket because I want to call a list of columns. So I'll come here and say sales channel, 3 players, and purchases. These are the 3 columns I want to extract. So let me just take this to the this thing. So you see that we have 3 of the columns, right? And now it is in a data frame format, right? Because it is not just one column. Once it is one column, it's automatically going to be a series. So I can come here and say head, all right, to give me the head. So one thing is that you have to understand the data type of that object you're working with. So once you know the data type, you can know the functions to use or the methods to apply on it. So this particular object now is still a data frame. All right, it's actually still a data frame. I can come here and I can say, I can pass it to a data frame. I can say sub df, right? I'll pass it into a variable and come here and say sub df.head. So this is like another data frame as well. And I can use all the functions and attributes I can use in a normal data frame on this new data frame I have created. All right. So you can see how flexible Pandas let us use play with our data frame, how flexible Pandas is, right? So there are a lot of things you can do. You can actually work like without limits, basically, when analyzing data in Pandas. So these are some of the things that you can easily just do in other softwares like Excel, although Excel is very flexible as well. But when it comes to like flexibility, programming is the best, right? So analyzing your data using a programming language is like the best way to analyze your data because there are a lot of things you can do and you can do them quickly as well. So once you know what you're doing. So this is like the way to extract multiple columns, all right, and assign them to a variable and also like display them the normal way you display your data frame. So these are just different things you can use, different functions and methods you can use to like just access your data frame. So this is basically how we can extract columns from our data frame, right? So let's just go on to the next thing. So we have what we call ilog and log, right? This basically this ilog mean index location, while this log mean location. So this ilog and log is used when you want to like get a particular row. You want to like extract a particular row from your data frame. So if I come here and I say df.ilog, right, if I just come and put my shift and tab here, you can see basically this is purely integer location based indexing for selection by position. All right. So this is basically what it does. So you see, you scroll down, you probably see some use cases. So this is how you can like extract part of your data frame, right? So the ilog is not necessarily, it's a function, let's just call it a function, but it goes with this particular brackets, all right? So if I come in and I put 0, it's going to give me the first row. So this is basically the first row, all right? Like the first row and all the columns as well. If I come in and I put 0, 1, it's going to give me the first, let me come here again so you understand what I'm saying. Let me display the data frame. Display df dot head. So now this 0 corresponds to what? This first row. And this 1 here corresponds to what? The first column. Sorry, the second column rather. So you remember how why I was talking about index, why I was talking about indexing in NumPy. Some of you were not really understanding why we're doing the indexing. You can now see the application of indexing. We want to get a particular value in our data frame, this internet now, right? So we are now using both the row index location and the column index location to get that particular to get this particular value. So every single value in our data frame has an index location that corresponds to the column index and the row index. All right, so let's just say, for instance, now I want to get this particular value here. What am I going to put in the ilog value in the ilog? I want to get this 243.0. Exactly. I'm going to use 2 and 3. So if I come here, I'll basically just see 2 and what? 3. And then I'm going to get 243.0. So you can see how things are beginning to take shape and come together, right? So that's basically, so if I come and I put this, sorry. This should be, let me be sure. Okay. So basically, what I was supposed to put here is a comma. So this one is going to be for the row, and for something like this. So let me see this 22, 4, 2, 4. All right. So this is basically what I was trying to. I was trying to like both index the column, the row, and the column as well. So in this case, this is still the same thing we did before. All right. This first one is going to be your row, and the second one is going to be your column. So the value corresponds to the row index and the column index. All right. So if I want to get like the first two rows, this is going to it's not working. Okay. Okay. Okay, fine. So if I want to get it to be a slicing, I can just do this. And so I'm just going to like do this to get a particular portion. Right? So if I want to get more columns, I can make it something like this to get more columns. So this is just basically going to correspond to the number of the index of our column and the index of our row for this one. So like I don't want to stress much on this. This is something that we already know. So just apply the NumPy knowledge you have on indexing and slicing to this particular ilog. So ilog is for getting your row values or both your row values and your column values from your data frame. So we also have another function called lock. So it is df.lock. So this lock it does basically the same thing, but it doesn't use the index. It doesn't use the index. It actually use the particular labels you have on your row or your column. So if I come here and I put 0, it's still going to give me, let me take this out of the way. It's still going to give me the same thing, all right? The reason why it's giving me the same thing is because our data frame has the index label to be the index, the integer index, the original integer index. So assuming I changed my index label, my row index label to something custom, right? Let's say each customer or each row has a unique ID, right? So that unique ID is what you're going to use in this particular case, all right? So basically, if I come here and I say, let's just continue with the index label, right? The index, integer index, I come in and say 0 to 5 for my row. And I come in and I say, I want a specific column. Let's say I want 2 columns. I'll come in and say sales channel. And then I would say trip type. Sales channel and trip type. So this is going to give me the same thing, right? So, but in this case, I'm using the actual column names instead of the index. So in this first part, I was using the index, all right? But in this case, I'm using the column names like to get the particular column I want. So This one is more specific because you know the particular column you want to index. All right, so you can just use the column names and then get the particular column that you want. So you can put as many columns as you want here, right, and as many row in there. So assuming your row here is not 0, 1, 2, 3, assuming it is, let's say, A, B, C, D, right, in letters, you can just put them here, slot them here, right. So that is what this lock is for. Why iLock is for index. So it uses strictly index for indexing. Why this particular lock uses your labels for indexing. So if you just do Shift Tab on this, you're going to see the documentation. It accesses a group of rows and columns by labels, all right? By labels. So this is very important to note, not by index, right? So lock.loc is primarily label based, right? So this is what I just want you to know. It's primarily label based. So it works with the particular label you are seeing. Why this iLock works with an index that you're not seeing, right? You're not seeing, you can't see the index yet. The reason why you're seeing this index is because it was like the default index that you had there. So, but most times it will be changed. It will not be the same in the default index. So you will probably not see the normal index. So you'd have to use your knowledge of indexing to get this particular iLock to work for you. Right? Why for lock? It's something it's based on what you're seeing here. So whatever it is you're seeing here is going to be used for indexing. So that is how you use your iLock and lock. So there are a lot of use case for it. So depending on what you're analyzing, you would have to use it in different ways or different combinations. So because we have a lot to look at, we're just going to leave it here. But we'll be working on next week, we're actually going to do we're going to analyze the data set actually, right, with goals in mind, right? So when we start that, we're going to now see how we can now use these different functions to achieve what we want to achieve. But the purpose of this class is just to introduce you to different functions you can and that you can use with pandas on your data frame, right? So this is it for iLock and lock. So what we have next here, so for attendance is on now. So you can actually go on and take your attendance. Just give me a minute so I can quickly make it available. Okay, yeah, so attendance is attendance is on. You can go and take your attendance. So this attendance basically ends stay till the end of the class. So don't allow yourself to be stressed so much about it. So let's move ahead. Let's move on. We don't plan to cover everything today. So I just want to introduce you to how we can use different work on your data frame basically. So I've showed you how we can select columns and rows. So you can select the column using indexing or using the attribute method, right? So you can also select use iLock also to select your rows. All right. So this is how what I've just explained already, right? So you can actually do what we call Boolean indexing. Right, you can do what we call Boolean indexing. And this is something that you actually be doing a lot. So Boolean indexing is basically using a conditional statement, right? A conditional statement to select a particular data or to filter out data. So in this case, you can see that we have this df dot your column greater than 25. So how does that work? So if I come here and I say, let me see all my thing again. Let's go straight to this. So let me get all my columns again. Df dot info. This is a function, so not an attribute. So there the info, I have this float. So let me see if I can use purchase lead, all right, or number of passengers. Let me use number of passengers, right? So I'm going to get number of passengers here. So I want to use I want to show you how to do Boolean indexing. So I'll come here and say number of passengers. So this is what I have. 2. Is that it's just 2 and 1? Okay. I'm just get a sample. Okay, I have 4. Maybe under sample 1. 3. All right, so let's just use this regardless. So I want to use Boolean indexing. I want to say, okay, I want Pandas now to give me only those rows are greater than not question mark, greater than 2, greater than 3. All right. If I run this, I'm going to get this false. So this thing you are seeing here is what we call Boolean mask. All right. Can everyone see the screen? Some people are complaining of network. Can everybody see the screen? All right, great. So what you are seeing here is what we call Boolean mask. So this doesn't make sense to do anything basically, right? But what you can do is that you're not going to kind of use this Boolean marks to get the true value. So out of all these false, there are some places that you have true value. So for you to get the data for those true value, you have to use this particular output to filter out your data. So I'm going to put it inside a bracket, which is the square bracket again. So we are literally filtering our data frame with this Boolean mask that we have here. So it is going to give us the data of only those true values. All right. So if I run this now, you're going to see we would have only those values that has their number of passengers greater than 3. So you can see if we check here, 4646, 84544. So we are not going to have any row where the number of passengers is less than 3. Right? So this is another way to kind of work with your data frame. Let's say you want to use a filter on your data frame. You can basically just use this method. You use the particular column you want to filter with and state that condition. So this is the conditional statement that we talked about initially. So this gives you a Boolean mask. That Boolean, why it's called Boolean mask is that the output consists of Boolean values which are true or false, right? So each row will either be true or false depending on this statement. So you're basically performing a conditional statement on all the rows in your data frame. So those rows that have true as the output, when you use this particular filtering method, you pass it into your data frame. You will not get the values for only rows that are true for this condition, right? So that's what we call Boolean indexing, all right? So it's called Boolean indexing. Although this is just a technical term, or you can call it filtering. This is what we know as filtering our data. So if you want to filter your data, you can basically use this method. So this is the same thing as coming to Excel and going to data tab and then coming to sort and filter and clicking on filter and coming to the column and selecting the particular column you want to filter by. The thing is just that you have more flexibility with this, right? You can specify the specific condition you want to filter with. Like you want to filter with this row, but you want this particular condition to be greater than so, right? You want to filter this based on this, but you want it to be so. There are a lot of things you can actually do with this particular Boolean indexing, but this is basically what it means, and this is how you can approach it. So that's basically it. You can come here and now pass it into a variable. You can say filtered df. All right. and then have it as a variable. And you can now come here and start working on the filter df as if it is a new data frame. If I come here and I say filter df, you see it here. You can see dot shape. You see out of all the 50,000 rows, we have just 2,900 rows that have passengers greater than 3. All right. So you have your column as well. Yeah, if you want to filter, what about filtering between two columns? I don't really get that question though. But if you want to select a particular column, you can still just come here and use this filter df to select the column you want, put the columns you want here, and pass into a variable, and you have those particular columns and the filtered rows, right, for yourself. So this is how you can perform Boolean indexing and filtering. You can do a lot of other things on this filter df and use it as well, and based on your analysis. So that's it for Boolean indexing. So we're now going to talk about data manipulation, how to add and remove columns. So now we've looked at how we can access our columns and rows and all of that. So now, how can we add new column based on existing data? So to add new column manually is going to be quite rigorous, right? You see, in this case, we have 50,000 rows. So if you want to start adding column manually, you will probably get exhausted. You probably not even finish it, right? But there are ways to add new columns to your data frame. So let's say I have let me just use this filter data frame. Filter data frame. So for this filter data frame, you can see that we have the indexing is now messed up, right? It's just rubbish, right? So you have 12, 37, 61. It's not like sequential. And you probably want to use this filtered df for your analysis. This is the particular data you need for your analysis. So to reset your index, there's a function for that which is called reset index. So if you push apply reset index to your df, you see that it's going to reset your index and it's going to now start from 0, 1, 2, 3. So the start index you had before will now be arranged for you. So there's something that you need to know in Pandas, a very, very important parameter or argument you need to know in Pandas. It is called in place. It is called in place. So anytime you perform a particular action in Pandas, most time it doesn't actually change the data frame, right? It just gives you the output. But if I come here now, right, here I've reset the index. If I come here and I call filtered df, you'll see that the index is still not reset, it's still scattered. Why? Because this particular operation or operations on Pandas data frame, they don't usually modify the original, or they don't really modify the data frame itself, right? They just give you an output without modifying it. So for you to modify or to apply the changes to that data frame, there's an argument that you always need to pass, which is called in place. So there are two ways to actually apply these changes. You can use in place, which is a keyword argument, equal to true. By default, in place is actually equal to false. If I come here and I use shift tab, you see that we have in place here, right? In place is what by default is equal to false. So if you check the meaning of in place, where is in place here? In place means whether to modify the data frame rather than creating a new one. Okay, so in place is basically going to just apply the changes to your data frame. So that data frame will now carry the new change that you've made. So if I make this in place here and I run it, it's going to apply the change, right? And if I come and I say filter df, wherever I call filter df, I'm going to have that reset index. So that's basically how you can apply your change. So this is the first way to do it. The second way to apply the change is just to pass the change into a variable. So I can come here and say filter df is equals to filtered df dot reset index. You don't need to put in place again here. So let me run this thing again. Let me comment this one out. So if I run filter df here, you see that filter df is now what? Oh no, I have it this cell down already. So I come here and run filter df. You see that filter df, I've already scattered it again, right? So if I come here and I say filter df the reset index, and I'm passing the output into the same filter df variable name. This is another way to actually implement changes to the database, or to the data frame rather. If I run it, it's going to pass it to filter df. And if I run filter df, it's going to give me. So these are the two methods of like applying your changes permanently. But if you just do this filtered index like this, thinking that you've already applied the change, no, if you've not applied the change, you might come here and like call on filtered index, and it's still giving you this the old stuff that you had, and you'll be wondering why it's not applying the changes to my data frame. So these are these little things that you need to pay attention to, and you'll probably come across as you're working on your on your data frame. All right, so just take note of that. So that is one way to like apply your changes permanently. It's not just for reset indexes, for a whole lot of other things that we're going to be looking at. I just wanted to show you how you can reset your index when you scatter your data frame. So that is it for resetting your index. So let's move on. I'm just going to come and see dot head. All right. All right, so the next thing we have here, okay, adding or removing columns. I wanted to show us how to add and remove columns. So let's say the columns that we have already. Let's say we have purchase lead, right? Let's say we have this purchase lead here. Let's use purchase lead. Or rather, let's use flight R. So I'm going to come here and see df flight hour. So this is our flight hour. This is our flight hour variable or column. So I want to create another new column and add it to our original data frame. All right. So I can come here and say, for this flight hour now, I want to create a new column. So the way to create a new column is to call the df and then put the column name that you want to create. Let's say flight hour times 2. Let's just use this as an example. Flight hour times 2. So what I want to do is I want to create a new column that multiplies each flight hour times 2. All right. So I can come here and say flight hour times 2, and I will say df flight hour. I will now say times 2. So this should add a new column to our data frame. All right, this should add a new column to our data frame, and this is working because of the data type of this flight hour. If you try this on string, it will work as well, because I think multiplication works on string. It will just multiply the string. But at some particular data type, you can try some operation, right? So that is why we give you the fundamentals that we gave you. So you not come here and start doing what is in your mind, all right? So once you do this and you come here to get your data frame, so to see your data frame columns, so if I say columns, so you see that we have a new column here, which is flight hours times 2. So if I say df.shape, our df has changed from 14 columns to 15 column, right? So if I now like say, let me just say my columns, I'll just say df.head. You see, I'm going to scroll. So it actually added the new column here. So when you use this particular method, it automatically adds it at the end. It kind of appends the new column to the end of your data frame. All right. So, but there's another function that you can use to insert it wherever you want to insert it, but that is going to be later on. But this is how you can actually add a new column to your data frame, right? So you just like create a variable. You use this format df, like as if you just like use the same syntax that you would use when you want to like access a column. But in this case, you're going to put the name of the new column here. So this is going to be a variable. So this variable is the new column. So, and then the value you're going to be passing to the new column should be of equal length or to the database. Or to, sorry, why do I keep saying database? To the data frame. So if your data frame is 50,000, any value you're going to be passing to it will be 50,000. So if I come here and say, okay, the actual length is what again? Let me just be sure. 50,17. So if I come here and say df.text column, and I come here and say df, or I say lists range 0 to 5015. Let me just use this. You see, I'm going to get an error. First of all, why am I going to get an error? Because the length doesn't match. Length of values 5011 does not match length of index 5017. So any value you're going to be passing, any column you're going to be creating, make sure that the value you're passing to that new column is of the same length. So if I make this 5017, you see it's going to work, right, without any problem. So if I come here and say df, so if I scroll to the last to have my text column there, so my text column is going to just be a range, basically, of this stuff that I have. So if I, let me see, change it to 10, and I make this 27, and I do this. So I'm going to have, I'm going to have this. So you can actually use the same method to edit or to like modify your previous data, your previous column. So anything you have here is going to be replaced by whatever you have here. So even if this thing is an existing column and you pass a new value to it, it's going to modify or replace the values of that column. So if this string here is a new column, then it's going to add the new column to your data frame. I hope that's clear. So that's basically how you can add columns to your data frame. So we can also drop columns as well. So very, very straightforward. So you use the df.drop function, dropping columns. So you use the df.drop function to drop your column. So df.drop. So it takes some argument. The first argument is the name of the column. So you don't do something like this df and then your column name. No. You just put the column name directly, because this drop column will already assume or know that this is the data frame you're working with, and it's going to look at this data frame for the column name. So if I come here and I put, what column am I going to use now? Let's say I want to drop, okay, there's something that happened that I'm going to explain now, but let's say I want to drop number passengers. I'll come here and say number passengers. All right, is it correct? Yes. Now there's another important argument that you need to specify, which is axis. Remember what I told you before? Axis one is what? Which axis is column and which axis is row? Quickly. Which axis is column and which axis is row? Exactly. So axis one is column, axis 0 is row. So if I need to specify, I need to tell this drop method which axis you need to look for number passengers. So if I tell it axis equals to 0, it's going to go and look for number of passengers in the row label. So if I run, it's going to give me an error because there's nothing like number passengers in the row label, right? So what it's doing right now, see the error here? Number passengers not found in axis, all right? But if I specify axis equal 1, then it's going to look for number passengers in the row, in the column label. So if I run this, it's going to like, yeah, exactly. So it's correct. So you see that I don't have number passengers again here. So it has dropped it for me. But if I come here and I and I run my df again, I'm still going to get number passenger. You can see, can someone tell us what we need to do to like make sure that this thing doesn't appear in our df quickly? Exactly. We're going to use the in place method, or what? Thank you very well, Musiba Odada. You're going to pass, either you pass it to a new name, a new variable. No, you don't need to pass it to a new variable. You need to pass it to the same variable name. You understand? You need to pass it to the same variable name. So I can either do something like this, df.drop, and then say in place equals to true, or I will say df equals to this. Come here and paste it. So these are the two methods. This one using the in place method, and this one using the what method did I even call this again? So I don't know, I'm forgetting things today. Okay. So using the in place method or using the variable method, let's just call it variable method. Variable method. All right, so these are the two ways to enforce your whatever it is that you did, your modification on your data frame. If you don't do this, no matter how you modify your data, no matter how many columns you drop, you're still going to have the original data frame, right? So we've not run this yet. So let's see. We can actually pass in multiple columns in it as a list. If I want to drop multiple columns, I can come here and say I want to drop this column, purchase lead. Let's say I want to drop these two columns, right? So if I come here and I say, you see that two of them have dropped. If I say df.shape, you can see, yeah, 14, because we added two new columns before. So it was 16, now it is 14. So I hope this is clear. I understand that this is getting overwhelming. So this is basically where we're going to stop for today. Then we're going to pick up from there. So quickly, I'm going to just show you how we can fill and do missing data. From next week, we're going to look at data aggregation and group operation, because this one is a whole lot stuff on its own. So we are going to really show you how we can handle missing data using fill NA and drop NA. So to handle missing data is one of the important things to look for when one of the most important things to look for when cleaning your data. So let's say I want to see all my missing data. So there's actually a function to help you know how many missing data you have. So I'll come here and say df.isNA. So what is NA does is a function actually. It creates what is this thing called? Can someone just quickly tell us what is this called? What is this called? What is this called? Quickly. No, it's not a Boolean. There was a word I used, a phrase rather. Yeah, it's no, not Boolean indexing. Not Boolean indexing. Yes, it's called a mask, a Boolean mask. All right. So you can't use this Boolean mask for anything. Right? For you to get something out of it, in this case, you actually just say dot sum. So this dot sum is an aggregation function. In this case, you remember what we did in the other one is that we actually use it as to filter our data. But in this case, you use your Boolean mask to get the number of not null data, all right, per column. So what it does is that it sums up all the values that are true. Remember when I said initially that true is equals to 1 and false is equals to 0. So when it adds up all the true values, it's going to give us a particular sum. So in this case, all columns have their own number of missing values. So the sales channel have 10 missing values. Trip type has 5, 7, 15, 4, 3, 11. So these are the number of missing values per column. All right. So, and you do that. The way you get that is by using this particular method. Is NA. NA is a function that is a conditional function actually, right? So is built in Pandas. So what it does is that it checks each value and compare it and check whether it is a missing value or not. A missing value, as I said, is what? NaN. So when you see NaN, it's basically how Pandas represent missing values. All right. So that's basically how his NA works, right? So when you check his NA, you use the sum to kind of aggregate it to get a meaningful response, right? A meaningful output rather. So you can see that we have a lot of missing values. Yeah, we need to actually work on this. So this is not a data cleaning class. We are going to do that one later, but I just want to show you we can use his NA, fill NA to replace missing values. So let's say we want to replace missing values for sales channel. So I'm going to come here and say, let's say fill NA. But we're going to talk about specific column data, but let's say we want to fill all our missing values. You can come here and say fill NA, but the way we do that actually is column by column because each column is different. So I can just come here and say, let me pick one column here, sales channel, or let me use an integer column. Let's say flight hour. And I will say fill NA. So I'm performing this particular fill NA on a specific column here. So I want to fill this. I want to fill this with, let's say, 5 or something, or let's say 5. But this is not an ideal thing to do. I'll come here and I'll run it. So it's going to fill all the missing values with 5 for me. But what you do ideally is by you fill the missing values with the mean of these particular column values, right? So let's say I fill them with 5. So you say everything will be replaced here, or it doesn't. You have to include this in place here. In place equal to true to make sure that the modification applies to it. All right. So if I come here and I run this, okay, let me run this thing again here, is NA, you see that this particular flight now is now what? 0. So I have literally removed all the missing value here. So you have to do that particular operation for each column. So this is part of the data analysis process. So you do it for each column. You ensure that you know the type of data that is in each column, and you know the kind of data you are replacing it with. If it's a categorical data, you replace it differently from a numerical data. So these are the things we're going to look moving forward. But for today's class, I think this introduction is going to suffice and help you like gain a proper understanding of how to work and manipulate your data frame. Work with your data frame and manipulate your data frame. All right. So we also have drop NA. What drop NA does is it just drops all the missing values basically. So drop NA is not something you do per column. You actually do it on your data frame generally. So if you drop NA, it's going to drop every missing value. It won't work until you put what, or let's just pass it to a new variable. If I come and say df.shape, you can see that it has reduced to 49,000 because it has dropped all the missing values. Right? So this is basically where we're going to stop for today. So I don't want to feed us with a lot so that we're not going to choke, right? So this probably should be enough for you to go back and like reflect and kind of digest so you get a better understanding of it, right? So when we come back next week, we're going to continue from here. So you can see how everything is beginning to make more sense. Everything we've learned so far is not irrelevant and is not in vain. They are needed for what we are going to be doing subsequently, all right? So that is going to be it for this class. We've actually looked at a lot today. We've looked at, let me go back here. We've looked at how we can perform basic data frame operations. We started from how we can import CSV files actually, right? Let me use this instead. We start with how we can import CSV files. So how we can import CSV files, I told you to make sure that this particular file name is in the same directory. Don't make that mistake, because I'll give you an assignment this week, and probably some of you would find that issue persistent. So make sure that you follow this instruction here. And I showed you how you can view your data frame using several functions, df.head, df.tail, df.sample. I showed you how you can get the column names, index, using info function to get a very comprehensive information about your data set, using your sample method on series objects, right? And also like getting your columns using two methods, either the indexing method or the attribute method, right? We also looked at how we can create a new data frame with a specific number of columns, right? We also looked at how we can use ilog and log. Ilog is using the specific index, while log is using the label, right? Not the index. So this index is what we did in NumPy. So just use the NumPy knowledge and apply it here, right? So we also looked at how we can filter our data set using Boolean indexing. Boolean indexing, and then we can reset our index, and that we can use in place to make sure that it's a permanent modification, right? We also looked at how we can create new columns, how we can modify and drop. We can also drop new columns as well. And I told that you make sure that the values you are passing is the same length as your columns as well. So we also looked at, I think we wrapped up with how we can work on missing values, whether by dropping them or by filling them with some value. So that's it for today's class. That is actually quite a lot, all right? So I would be dropping this video. Yesterday video is not out yet, so when it is out, I'm going to drop it alongside this video. It will be to your great benefit to go through this video before you attempt your assignment. So that's going to be it for today's class. If you have any question, please just indicate by raising your hand, and you can ask right away. So I won't be taking much question. Philip Solomon, ask your question quickly, please.
Okay, good evening, sir.
Yeah, good evening.
Yeah, I want to ask based on the drop. At what point can we decide to drop all missing values, or decide to fill those missing values with other values of our choice? Is there a criteria or rules that we can decide this? Yeah.
I get your question. So this is a good question. And this particular class is not for data cleaning. We're just trying to explore some functions and methods. So when we get to cleaning our data, we're going to dedicate a class for that next week, which will be next week Saturday. And we're going to I'm going to take you through how to think like a data analyst, how to decide what to do when you have a data set, because data set brings with it different problems. So it is the approach you're going to use is peculiar to the data set you're working on. So there's some data set that you can just drop everything. So there's a general rule that if your data set is very large, right, you can actually just drop all the missing values if it will not affect your data. All right. So, but there's some that are some data sets that are not so large, that dropping your missing values actually affect the size and the analysis that you're going to get out of it. So mostly when your data set is very large, like this 50,000, you can actually drop your missing values. It won't really affect it, all right? So these are just some general rules. But when we get to data cleaning itself, we can now decide how to do it and which approach to take, all right? That's a good question. Ayomide, your hand is up. Please ask your question quickly.
Good evening, sir.
Good evening.
Please, I have two questions. The first one is that is it only CSV data file that we can use this pandas? Can we also use it for maybe Excel and other data files?
Yeah. Okay. Now, second question.
And then the second question is that when we were doing the new colon, the part where you wanted to add a list of range of numbers, you used bracket, the normal bracket instead of the square bracket. I don't know if that's supposed
Okay,
to
your
be.
first question. Yes, you can actually use other files. As I mentioned at the beginning of the class, you read Excel file, you can read CSV file. Those are the two major files you can read, right? So you can even read HTML file. There are a lot of. Let me just quickly show you here. So you see we have DIRGD print. So if you scroll down, you see we have read CSV here. We have read clipboard, read CSV, read Excel, read Fedora, read this, read that, read HTML, read JSON, read. So you can read the or the type of files you can read Excel is a lot. So the reason why we use CSV is because it's the most common one that we use. Like it's very, very common. All right, that's why we're using CSV. And Excel as well. That sometimes you also use Excel, read Excel directly, right? So I think we're going to look at that like maybe briefly in the next class, but this is mostly what you're going to be using, CSV file. And for the second question, when I was assigning, let me see if I can see it here.
Mm,
But I get your question, Sha. When I was trying to create a new column, right? Yeah,
yes,
I use the
yes.
list. List is a function, so I don't. It has a square normal bracket, not square bracket, and range is also a function, so it should have its normal bracket. So what I'm getting, you don't necessarily have to use a colon value to generate a new column. You can use any value as long as the length of that value is equal to the length of the data frame. That's fine. All right. The reason why I use the square bracket is because I'm trying to index the column name of that data frame. But if you are doing something out of the data frame, you just use the normal stuff that you know. All right. So that's why I think I don't know. I'm not seeing this here, so you can just yes. Okay, see it here. So we have
Yes,
lists.
yes.
So which bracket are you talking about here?
Yeah, the normal bracket you you use to enclose the range.
Yeah, this is range function. You should have this normal bracket, not square bracket.
Okay.
The same thing with list as well. So this is going to give you an output of values, a list of values, which will now be passed into this particular data frame um, column. So I think that answers your question. So with no
Yes,
other
thank
question, I'm going to be calling it in. So thank you very, very much for your and yeah, you're going to be, this video is going to be made available for you to go through. I know most of us want to go through the video again to take our time and digest it because of a lot of number of volume of information that will pass through. And yeah, assignment to be given this week as well, which will test you as well and to make you practice what we've done. So the CSV file that I use, I will send it. Please, class rep, remind me of that to send to the material resource group just so you can practice with it as well. So with that, we're going to be drawing the curtain for today's class. Thank you very much for your time and do have a splendid night and enjoy your week. Don't forget to do the full. Don't forget to do the needful. And tell us what you learned in this class. And like again, I'm going to go through them and then compare to us with how you know the concept. So thank you. And